Hello and welcome to our video today. So we shall be discussing balancing of chemical equation. So to simplify, a balanced chemical equation is when the number of similar atoms on the reactant side is the same as the number of atoms on the product side. So for example, Na plus Cl, so sodium and chloride, can make sodium chloride. If you notice in this equation, the number of sodium is the same as the number of your sodium on the reactant. So the product, same with the reactant, chlorine and chlorine, one chlorine, one chlorine, one sodium, one sodium. So that is a balanced equation wherein if you count how many chlorine or how many sodium or how many hydrogen or how many carbon, they should be the same. And that concept is based off of this idea, the law of conservation of mass. This is Antoine Lavoisier. He was the one that explained this idea. So he was doing a lot of chemical reactions, and one of the things that he noticed is that the mass of the reactant and the mass of the product will always be the same. So for example, if he made carbon and oxygen to interact, so he would measure the amount of carbon that he has and the amount of oxygen that he has. After the reaction, you will have carbon monoxide and carbon dioxide. However, the total mass is still going to be the same. And that's why the idea of the law of conservation of mass was developed. So the idea for balancing is following this concept, and I'll show you how. So this is a chemical equation. Let's try to identify whether this is balanced or not. So let's try it. You'll have here iron, you have here chloride, you'll have here chlorine, you'll have here magnesium, and then you'll have oxygen as well. So just place an equal sign. So everything that is related to the reactant side we'll write on the left side, in this side, and then for the product side we'll use this one. So how many iron does the reactant side have? It has 1. How many chlorine? You'll have 3. How many magnesium? You'll have 1. How many oxygen? You'll have 1. So how many iron? You'll have 2. How many oxygen? You have 3. How many magnesium? 1. And 2 for chlorine. The idea for balancing is to make sure that the law of conservation of mass will be followed, because you can't make 2 iron out of 1. Okay? You can't produce just 2 chlorines from 3. That's very impossible. So, according to the law of conservation of mass, mass or material cannot be created nor destroyed. Now, how do we balance this equation? The only thing that you have to do is this: change the coefficient. So you have here the number before each of the compounds, so just change it. The current number of this is 1. So you'll increase it by 2, 3, 4, 5 until you will be able to balance, okay? But if possible, the number of coefficient would be lower, if possible. So balancing the equation is going to be a trial and error. You're not going to have the final answer right away. So let's try to balance this one out. So to balance, you need to find the greatest common factor. So the common factor between 1 and 2, the greatest common factor would be 2. So to make this a balanced equation, just change the coefficient to 2. 2 times 1, 2. Then another thing that you do, if you change the coefficient, you multiply it with the other element. So 2 times 3, that becomes 6. So 2 times 3, 6. So your chlorine is 6. Your iron is balanced, your chlorine is not. So maybe you can fix that too. So let's try to fix that. Let's balance your chlorine. So multiply this by 2. Is that right? No. Since you have 6, just multiply it by 3. So 3 times 6, you'll have 6. So 3 times 2, that becomes 6. So the number of chlorine is going to be 6. Now you'll have to multiply magnesium as well. So 3 times 1 is going to be 3. Now, anything that still needs solving, I think that would be your magnesium and your oxygen. If you've noticed, since both of them are 1 and they are lacking, they need to be 3, all you have to do is multiply them by 3. 3 times 1, 3 times 1, so you'll end up with 3 and a 3. Then just write 1 here because there's nothing to be changed. I mean, you don't have to change the coefficient of this molecule because this is already a balanced equation. The number of iron is the same, the number of chlorine is the same, the number of magnesium and oxygen are the same. So that's how you balance an equation. Let's try more examples. So this one. Okay, remember, write everything first. Li, H, P, and O. So let's count the number of Li on the product side. Li has 3, H has 2, P has 1, and O has 4. For the reactant side, 4, 1, 3, and 1. So this one you have isolated molecules, so that would be the last thing that you have to consider. So let's find the greatest common factor. So this one, the greatest common factor between these two is going to be 6. So let's transform this one of this into 6. So to transform this to 6, you have multiplied by 2. 2 times 3, this becomes 6. 2 times 1 becomes 2. 2 times 4, this becomes 8. Now, anything that needs fixing, I think your oxygen needs fixing, your phosphate needs fixing. So let's multiply it by 2 as well. So 2 times 3, this becomes 6. 2 times 1, this becomes 2. 2 times 4, this becomes 8. And then you have two remaining things that needs fixing. These are your solo atom molecules, so just multiply them easily. So for lithium, it needs to become 6, so multiply it by 6 since this is just 1. 6 times 1, you'll have 6, and to make this a 6, just multiply this one by 3. 3 times 2, you have 6, and you have a balanced equation. Let's move on to the next one. Oh, by the way, I forgot to cancel. Let's move on to the next one. So, again, step number 1, write everything. Zinc, sulfur, and oxygen. By the way, balancing, trial and error. It doesn't have to be perfect right away. So, zinc 1, sulfur 1, oxygen 2. Zinc 1, sulfur 1. Now, for this one, you have 2 separated oxygen. All you have to do is count them, 1 and 2, and then you add. So 1 plus 2 becomes 3. That's very problematic because this is an odd number. So to make this even, try to use the smallest. So just multiply this by 2. So 2 times 1, your zinc becomes 2. 2 times 1, your oxygen becomes 2. 2 plus 2, your oxygen becomes 4. Now, anything that needs fixing, I think let's try to focus on your zinc first. So zinc, since oxygen is an isolated one, we'll do that last. So let's make zinc 2. So 2 times 1, zinc becomes 2. 2 times 1, sulfur becomes 2. Now this one, your sulfur has a problem too. So just multiply it by 2 because the common between 2 and 1 is 2. 2 times 1, 2. 2 times 2, this becomes 4. So 4 plus 2 becomes 6. Now, to balance this equation, just multiply your oxygen gas by 3. So 3 times 2 is 6. That's how you balance this equation. Now, let's go on to this one. Oh, yeah. Maybe I'll just give this to you as a problem to try, and then I'll come back by the end of the video and show you the answer. So let's go on to the last one, or the more difficult problem. So this is a difficult, maybe at least intermediate to difficult type of problem. So write everything first. Carbon, hydrogen, oxygen, and nitrogen. So how many carbon on the reactant side? Carbon on the reactant side is 5. Hydrogen is 13. Oxygen is 2. And then your nitrogen is 1. Nitrogen is 1. Oxygen is 2. 2, 1, 2. That means it's 5. Hydrogen is 2. Carbon is 1. So, The way to balance this is you might want to focus to 5 right away, but if you notice, try to focus on the bigger numbers first. So for example, this one, H. 13 and 2. What's the common number, or I mean, what's the greatest common factor? That's not 13, that would be 26. So how do I make this 26? Multiply this one by 2. Again, this is a trial and error. This is not your final answer. This could change. So 2 times 13, that's going to be 26. 2 times 5, this becomes 10. 2 times 1, that becomes 2. So your nitrogen becomes 2. So imagine if I tried to solve carbon first. If I multiply this with 5 right away, I would be wrong. So it seems like I can multiply this one by 10. So let's write 10. 10 times 1, your carbon becomes 10. And then 10 times 2, your oxygen becomes 20. Now, oxygen becomes 20 plus 1 plus 2. So your oxygen becomes 13. Now, anything that we can fix. So the hydrogen now is going to be much easier to manipulate. So let's try to multiply it by 13 because remember, 13 is what we were looking for a while ago. 13 times 2, you'll have 26. Now, 13 times 1, this becomes 13 as well. So your oxygen count keeps on changing. So 13 plus 20 is going to be 33 plus 2. That will be your 35. Now, another thing is your nitrogen is not the same. So since this is 2, just multiply this one, but since this is 1, you just multiply it by 2. 2 times 1, your nitrogen becomes 2. 2 times 2, your oxygen becomes 4. So 20 plus 13 plus 4 is going to be 37. So your oxygen now is going to be 37. If you've noticed, your carbon count is the same, 10, 10. Your hydrogen count is 26 and 26. Your nitrogen is 2 and 2. The main problem is your oxygen now is 2 and 37. And the only common thing that they have is 74. So to make O2 74, you have to multiply it by 37. Now, if I multiply it by 37, it's still not balanced because that would be 74. Okay, so let's just say I do that. This will become 74. So to balance this, what I have to do is I have to divide 37 by 2, which is not a whole number. So what I have to do now is instead of dividing it by 2, I can multiply the rest of the coefficient by 2. So if I multiply this by 2, this becomes 4. So instead of using 2, this becomes 4. This becomes 20. This becomes 26. And this one becomes 4. So 4 times 5, you'll have 20. And then 20 times 4 times 13, then you'll have 52. And then 4 times 2, that means you'll have 4. And then to try to solve the other things, so 20 times 1, your carbon is going to be 20. 20 times 2, your oxygen is going to be 40. Plus, okay, 26 times 2 is going to be 52 as well. And then 26 times 1 is going to be 26. So 40 plus 26. And then 4 times 1 is going to be 4. So your nitrogen becomes 4. And 4 times 2 becomes 8. And then 40 plus 26 plus 8 is going to be 74. So that's how you balance your equation. Now, for the last item, let's go back and we'll see what is your final answer. So let's go to the previous problem that I showed you a while ago. So this is going to be your final answer. So remember, just try to do a trial and error, and you'll be able to finalize and balance an equation for this one. I hope that you learned something for this video and hope you learned something for the next video as well. Bye!